Hello, welcome back to Cinderella Math. Today I'll be doing the SOAP method for factoring difference and sum of cubes. SOAP is just a cute little acronym to help you remember it. There's not really actually another method to do this. It's just commonly called SOAP. This should be a very quick video here. So this can only happen with either a difference of cubes or a sum of cubes, and we're talking perfect cubes here. So my example, number one, I'll do difference of cubes first, but they really do go very similarly. Let's have x cubed minus 125. So you do need to, for this method to work, you do need to have both perfect cubes. So if you think, is x cubed a perfect cube? Yes, it is, because it's x times x times x. So three things make x cubed, three of the same things make x cubed. And is 125 a perfect cube? Yes, it is, because 5 times 5 times 5. So 5 cubed is 125. So if these are not perfect cubes, you can't do it. Okay? So now that we have confirmed these are perfect cubes, the factors, you're going to set up a little parenthesis and then a longer one. You're going to take the cube root, so that's just x, and the cube root, which is just 5. So we kind of did that work off to the side. If you can do that in your head, by all means. And see this symbol right here being a minus? You're going to keep that the same. So put an S right there. That's going to stay the same. Into the big parenthesis, you're going to take this x, the first thingy, to the left side, and square it. So that's going to be x squared. Take the back number, ignore that it's a minus 5, just it's 5, and square it. So that's 25. Okay? And that's positive 25. And then in the middle, you'll see I've left a gap. You're going to multiply these together. And again, ignore the symbol. X times 5 is 5x. And then still we need a symbol right there. You're going to do the opposite of whatever you put in the first little parenthesis. So since I have a minus, this is going to be a plus, and that was the opposite sign. And this back sign is always positive because when you square something, whether it's negative or positive, it's always positive. So this would be your final factorization of x cubed minus 25. We have x minus 5 and x squared plus 5x plus 25. Now, I'm not going to be solving these today. I'm not going to be getting the roots or the zeros or the solutions. I can do that another day, but right now I'm just factoring. All right, I will do one more difference of cubes. Do 8y cubed minus, let's see here, 343. So if you don't know your perfect cubes by heart, it's fine. Grab your calculator, that can help you out, or we can just come off to the side. Is 8 a perfect cube? Well, 8's 4 times 2, and that's 2 times 2, so yes. There's 3 2's, so 8 is 2 cubed. And is 343 a perfect cube? Yes. That's 49 times 7, which is 7, 7. So there's 3 7s. So there we are. They are both perfect cubes. Again, if you already know that, or if you want to use your calculator to help you there, it's fine. Now that we've confirmed they're both perfect cubes, we set up a little parenthesis and then a bigger one. We take the cube root, and I kind of already did that off to the side, or you might just know in your head, cube root of 8 is 2. And then this y cube, if you cube root it, that'll be y. Take the cube root, which again, we already did off to the side, and that was 7. See this minus? Keep it the same, s. Okay. Take your front thingy and square it. 2y squared is 4y squared. Back thing and square it. So that's 49, and that goes in the back. And that's positive, because anything squared is positive. And then multiply these together. 2y times 7, and ignore the symbol, would just be 14y. And see how this sign was minus? You're going to do the opposite sign. and this one's always positive. And you can see why it's called SOAP. I don't think I said that before. SOAP. Keep this the same. The middle one here is the opposite of what you did first, and this back one is always positive. And that's difference of squares. Good news, difference of cubes. Good news, sum of cubes goes the same way. Let's do 64a cubed plus 1. Again, you may not need to do this step, but they do both need to be perfect cubes. Is 64 a perfect cube? That's 16 times 4, which is 4 times 4. So yes, 64 is 4 cubed, and 1, of course, is 1 cubed. So they are both perfect cubes. Little parenthesis, big parenthesis. And you're going to do the same exact thing. Take the cube root, which we kind of did off to the side, or you might just know the cube root of 64 is 4, and cube root of this guy would be a. Take the cube root, which is 1, and keep the same sign. So since we started with the plus, keep it the same. Take this front guy, square it. 4 squared is 16, a squared is a squared. Back guy, square it. 1 squared is 1, and that's always positive because anything squared is positive. Multiply these together. That's 4a, and do the opposite sign from the little guy. Same, opposite, always positive. So the factorization of 64a cubed minus 1 is 4a plus 1 and 16a squared minus 4a plus 1. Again, another day I might solve this out, but for now we're just factoring. I will do one more sum and then I'm going to call it a day here. Let's see. Let's do m cubed plus 216. Are those both perfect cubes? Well, m cubed, of course, is just m times m times m. And 216, if you break that down, that's 6 times 36, 6, 6. So 3 sixes. So these are both perfect cubes. Again, you don't really have to do that part. If you can do it in your head or use your calculator, that's fine. Once you know they're both perfect cubes, you set up your little and your big. Take the cube root, which will be m. Take the cube root, which is 6. Keep the same sign that's in the original problem, the same. Take the front guy, square it, which is m squared. Back guy, square it, which is 36. Anything squared is going to be always positive. And now multiply together, which is 6m, and do the opposite sign. SOAP, SOAP. And there we go. That is how you factor perfect cubes, either the difference of perfect cubes or the sum of perfect cubes. Again, I didn't solve this today. That can be for another day. What's going to happen is the little one is typically going to solve nice, right? You're going to set that to 0, and that's going to be m equals -6. This one's going to be a mess. The quadratic, you're going to have to do quadratic formula. It's a mess. We'll save that for another day. All right, I hope you enjoyed this video on using the SOAP method for the difference or sums of cubes. Hope you're having a great day, and I'll see you again soon. Bye-bye.